Our next discussion is called Designing a Healthy, Productive City. Cities hold a lot of people, but they can still be designed to promote good health, well-being, and productivity. Our moderator for this panel is Mark Fischetti. He's a senior editor at Scientific American. Mark, take it away.
Thank you. There we are. Wonderful. Thank you all. I'm Mark Fischetti, senior editor of sustainability at Scientific American, which is why I'm here. We have a great panel. Thank you for coming right back after lunch. Our news editor at Scientific American, Dean Visser is his name, used to work for AP, Associated Press. He was in Singapore for 8 years, and he told me the only thing I needed to know about Singapore is about food. And I have to say, lunch was really quite nice. So I'm glad Singapore is about food, personally. So we're going to start. I'm going to introduce each person, just give you their name and title. We're going to run this a little differently. So I have, much to their chagrin, I have said they each have 3 minutes to tell us basically what they do, and in so doing, answer a question that I have for them. So we're going to start with Lena Chan, who's the Senior Director of International Biodiversity Conservation Division at the National Parks Board of Singapore. So Lena, in 3 minutes, tell us a bit about what you do, and in so doing, can you answer this question, please? Can you explain the term biophilic urbanism, and tell us if this leads to new theories about how cities can kind of become a natural system?
I've been sort of associated with biodiversity for a long, long time. And in case people don't know, if all the humans die, biodiversity will survive happily. But if, biodiversity goes, we are in for it. We need biodiversity, especially in Singapore, food, because we talk about food, it's all about biodiversity. So that's like 2 minutes of my time already, right? Okay, catch up time now. I used to head the National Biodiversity Center of the National Parks Board. And what the National Biodiversity does is it's a one-stop center for anything to do with biodiversity. So government departments, international agencies, all that, come to us to ask for information. But we feel that it is so important that you cannot love something unless you know it. So that is why that is our connection with science, that we need to know more about it. And it's not only the scientist who does science, the citizen science. So that is where we are going into, making sure that everyone bring out the citizen scientists in every one of us so that we are aware of what biodiversity we have. So the next point is there biodiversity in Singapore? That actually leads to biophilic urbanism. And yes, in Singapore, we have, I think I mentioned before, we have about 397 bird species that land in Singapore. So that's almost about 4% of the world's bird population. And we have about 225, not only terrestrial, but also marine. So we harbor about 225 species of hard corals, and that is about 1/3 of the world's species, yeah? So how does that relate with healthy, productive city and biophilic?
Okay, Lena, I'm going to stop you there because I want to ask you that.
Yes.
When we talk about questions, and it's 3 minutes, I'm sorry.
Oh, okay, yeah. We'll talk more about that.
We will talk more about that for sure.
Yeah, okay.
Okay, thank you, Lena. Our next panelist is Peter Newman. He's a professor of sustainability at Curtin University in Australia. Peter, can you tell us briefly what you do, and in so doing, can you tell us about the relationship between density, transportation, and energy?
Okay, I'm a professor of sustainability at Curtin University, keeping up the Australian end of the panels. But we make films, and one of them was on Singapore, Biophilic City. So you can watch that on YouTube. It's had 200,000 hits, and it features Lena Chan, and she says things much clearer than she did then. The reason I got into density, and Singapore does density well, which is what a lot of this panel is about, is because I went to Stanford in 1973 when the first oil embargo happened, the OPEC one, and nobody could tell me why some cities needed less oil than others, because there was no data on it. So I began a career collecting data on cities. In our first publication, we had 33 cities. It took us 12 years to collect that data by hand, going around to every city, weighing maps of how the area of cities. Extraordinary stuff when you look at it now. But we found, when we first published that, there was a very clear relationship between the density of the city and how much car use there was, and therefore fuel use. And it was exponential. And since that time, we've got 100 cities in our global cities database, and they very clearly fit this graph, showing that as density increases, car use decreases, fuel use decreases. So increasing density and facilitating density is a very critical policy, not just for climate change, but for making healthy and productive cities, because highly sprawled cities are not healthy and productive. So the work we've done is being published many times in books and things, but mostly we get involved in very policy-oriented debates. I'm now on the IPCC, where I look after transport, and in particular, how we can make cities reducing fossil fuels. Singapore does well on how to get good public transport. It doesn't do well on renewable energy, and I'll talk about that sometime later this afternoon, I'm sure, because it is a major agenda that is being left off in Singapore. But certainly the whole way in which you do sub-centres linked together by good public transport with highly livable areas around stations, that's what every city has to try to emulate.
Great, thank you, Peter. A couple quick things. Yes, I'm happy to say this panel represents 4 continents and 2 hemispheres, and there's only 2. So, thank you for being part of that, Peter. Also, if you're curious and you're not sure who's who up here, we are sitting left to right as those are listed top to bottom, except for me. So next is Wah Tong. He is the co-director of Energy and Environmental Sustainability Solutions for Megacities at National University of Singapore. So, Wah, tell us a little bit about what you do and how can city governments manage the increasing amounts of waste in ways that kind of also promote well-being and productive cities?
Thank you, Mark. I'm from the Department of Chemical and Biomolecular Engineering at the National University of Singapore, but recently I've been leading this program, the Energy and Environmental Sustainability Solutions for Megacities. This is a program that is funded by the National Research Foundation under its CREATE umbrella, where universities from around the world come to Singapore to set up laboratories. And our program is a collaboration between NUS and Shanghai Jiao Tong University. And we look at 2 major areas in providing solutions to cities on sustainability. These 2 areas are waste management and on emerging contaminants. So I'll talk about the waste management part as Mark asked. In Shanghai and Singapore, you see 2 examples of very different ways of managing waste in cities. So Singapore, as most of you might know, we collect all of the waste that you dispose of sort of invisibly. You throw it down the chute and it gets collected somewhere, and it gets sent to the incinerator, and all of this gets incinerated. In Shanghai, though, there's a totally different way of managing the waste. So there's most of the high-rise buildings don't have chutes. You have to bring down your waste to a central collection area in the condos or the apartment buildings where you live, and it gets collected by all these garbage trucks, so you can see them. So what we are interested in studying in this is not just providing one solution, but we're looking at systems approach to developing different approaches for different cities, because what works for Singapore might not work for Shanghai, might not work for London or Melbourne or Sydney or any country or any other city around the world. So we want to collect the data, like what Peter said just now, all the data about waste management in the cities of different densities, especially very dense ones, and look at what would be the best solution to manage it in terms of economics, environment, sustainability, and a whole range of other methods like public policy, social behavior, education, and so on. So we want to combine all of this. Our team is very diverse. We have people from environmental engineering to chemical engineering, computer science to public policy, and we even have social scientists in our team. So we try to gather all this information and put it into a computer program. I don't want to overuse the word smart, but in a way, it is not that smart. Our system is actually very interesting. You have a three-dimensional map of the city, and then it has all the buildings plotted where the wastes are generated, so we have all those data in Singapore. And if you key in certain parameters that you want to optimize in terms of transport, like how many collection trucks are going to go around, what kind of trucks you want to use, or when did they go. You can optimize the location of the pickup, or even have decentralized solution. For example, if you don't want to collect the waste and send it all the way to a landfill 100 miles away, you want to just process it right on site, we can come up with different solutions that are suitable for different sizes of the amount of waste that's being collected. So I hope that will enable people to think about well-being in the city and environmental health.
Great, good, thank you, General. We'll do, as you know, we'll do questions after we've gone through the panel. We're going to talk about some things ourselves and then open it up to you all, so take notes. Jane Wernick is the director of Jane Wernick and Associates in London, and she's also a consultant and structural engineer with engineers, HRW, right, sorry. So Jane, tell us a bit about what you do, and tell us about one or two other major ways in which we can design the built environment to promote happiness and well-being.
Hello, well thank you for inviting me. So I'm the practicing structural engineer on the panel, as opposed to all these other academics who I'm surrounded by. I worked for many years for Arup, started their office in Los Angeles in '86, and then about 20 years ago left to form my own practice. Along the way I got interested in teaching architects, in fact, so I would not just be teaching them about engineering, but getting involved in the conversation about total architecture, which is what O'Varrick himself always espoused. I've also been a member of a couple of think tanks. This is based in the UK. One is called The Edge. We're a multidisciplinary built environment think tank, and we try to raise topics for conversation by organising debates, and we try to invite people involved in government to come along to these debates, so tackling issues like sustainability, the role of the professions, ethics, lots of different topics. And then there's another think tank called RIBA, Building Futures, and when I was with them I edited a book called Building Happiness, Architecture to Make You Smile. And it's basically a collection of essays by practitioners in lots of related fields, so a services engineer, architects, urban planner. There was a very interesting essay by someone called Hilary Geit who looked at housing in Greenwich and how the way that the buildings were organised would affect levels of depression. And since then I've become more and more interested in how the way we design the built environment can affect our psyche. And a lot of consistent themes emerge. A lot of it is, as has been mentioned earlier in the day, I think, common sense. People feel happier if they have some control over their destiny. I mean, even things like if you're in a tall building and you have to use the elevator to go up and down, apparently you're going to feel slightly happier in this awkward situation in the elevator if you're standing by the panel with the knobs on. But other things which are important in the way we design our public realm is to allow for places for chance encounters, so that you might meet a neighbour. Then also the effect of, if you're in a single aspect dwelling where you only ever face north and you never see a shaft of sunlight coming into your room, that's not such a good idea. So I think for us as designers, our responsibility is, I think, to always put ourselves in the place of the human being when we're designing spaces and try and imagine what you'll feel like. And it's going to be different in different parts of the world, obviously. So in the UK, we're desperate actually to get a bit of sunshine on our faces when we're sitting, outside a cafe. And in another place, you're desperate to have the shade. So we have to be sensitive to that, but keep on thinking about what are the moves we can make that will make people have a chance to smile.
Great, thank you, Jane. And on the far end of the dais for me is Geoffrey West. Geoffrey's a theoretical physicist, a senior fellow at Los Alamos National Laboratory. He's a professor now at Santa Fe Institute, but was as a past president of the Santa Fe Institute. So Geoffrey, tell us a little bit about what you're doing these days and where we are in developing a quantitative science of cities.
Yeah, so I'm, as was said, a theoretical physicist who migrated out of quarks and gluons and string theory and dark matter into questions, big questions in biology, and to understand sort of a big picture view of biology. And that led ultimately to thinking about cities and companies, actually, social organizations. First of all, thinking of them as organisms, and then realizing ultimately that there's obviously something quite different about cities than there is about organisms. But the work in biology was very much in the spirit of a physicist, that is, trying to make it quantitative, predictive, based on generic principles, and very much looking at the big picture. And some of that got expressed by two concepts that transferred over to cities. One was the idea of scale. So to what extent is an elephant a scaled up mouse, or to take it even more extreme, to what extent is a whale a scaled up human being, which is a scaled up, scaled down giraffe. So answering those questions and understanding those, and seeing that despite the extraordinary the extraordinary history of life, in the sense that by natural selection one would expect great variance, what one discovered that in terms of looking across large scales, that we are indeed at the sort of 80–90% scaled versions of each other as organisms. And they follow very simple rules, which comes to the second point, that those can all be derived from the mathematics and physics of networks. So that paradigm was taken over to cities, originally just to ask the question, to what extent, if any, for example, in the United States, is New York a scaled up Los Angeles, which is a scaled up Chicago, which is scaled up Santa Fe, which is where I live. Scaled up meaning in terms of any metric that you can characterize a city by, everything from the length of all the roads, or the number of gasoline stations, to the number of patents it produces, the number of AIDS cases, etc. And what we discovered was that there was an extraordinary universality to these metrics. Not only did, say, the number of patents as a function of city size scale the same way across urban systems across the globe, but they scaled in the same way as every other socioeconomic metric. And that could be understood within the sort of principle of mathematical framework as recognizing that they're all derivative of what you're really talking about, which is that they're all derivative from the fact that cities are a machine made to facilitate and encourage social interaction, create social networking, so that we can innovate, create ideas, create wealth, and improve standards and quality of life. And so it was the mathematics of social networks, and most challenging how those integrate with the physicality of a city in terms of its infrastructural networks, the transportation networks, and the resource networks. This is incipient work. I think we're still scratching the surface, and I think it's a fundamental question as to how far one can push a science of cities, as distinct, by the way, from an urban science,
right,
which we can maybe discuss.
Right, great, thank you, Geoffrey. So we're going to do some discussion for a while, not in any particular order, so we're going to talk about some concepts. One concept you've heard already a few times is density. So I'd like to start with Peter. One big factor Well, I guess let's talk about the desirable range of urban densities, right, to help solve sustainability issues. What densities make sustainability difficult to achieve and why? And then I'm going to encourage the panel to jump in briefly when they have something to say, but in this case, Jane is working on density too, so maybe the people can start, and Jane, you could jump in.
Okay. Our theory of urban fabrics, which was published a few years ago, talks about 3 cities in every city, and I think everyone can relate to this. There's a walking city, which was built before any mechanised transport, and they are dense and walkable. That's how they were built, and they're only a few kilometres across. Then the trams and the trains came and spread the cities out along corridors. So there's the transit city around that, and it goes out about 20 kilometres or so, and that's medium density. And then the car-based city came from the 40s and 50s on, and for most of the last century, car-based cities have dominated the world, and many of them, like my own, are mainly car-based cities, and their densities are low. What we're seeing now is that these cities need and want to come back in. The demand by young people in particular is to come back in. So there's the demand for density, but where? So Melbourne, for example, has talked about, this very high density city with 80% apartments. That's very much in demand to live in, but you can't put everyone in that. So you've got to have high densities, which are well over 100 people per hectare, in the walkable town centres. And you can really go high rise there, because that is appropriate to live in a walkable environment. The transit densities are generally around the 40 to 50 people per hectare, about half of that density, and it's very hard to go much higher than that. So if you plonk up a big high-rise building in the middle of that transit-oriented development, people will object, and there's good reasons for it, but it doesn't fit. But medium density does, whereas out in the suburbs, about the only thing we've had before were low densities. And the demand is now to put rail lines out into those suburbs and build density around them.
Right.
So building suburb-centred cities into the suburbs. That's the new agenda which is happening everywhere and is very much on the agenda in America and Australia, where we did low density very well, but now are suffering from it. Because it's so car dependent, the traffic's terrible, we're using too much fuel and all of that. And they're not very healthy. So if you think about the 3 city types, there's 3 kinds of density needed, but in the low density areas, if you're just continuing to sprawl, you're going to be ruining that city, not rebuilding it in a more sustainable way.
Great. Jane, you have a little different angle on density.
So, I totally agree with the concept that high density can produce a much better living and working environment, because you can either walk to work or you can have a much more efficient public transport system. And I've lived both in Los Angeles and in London, and of course Los Angeles is the great big sprawl and it suffers from terrible pollution. Not that London doesn't suffer from pollution, but I can go everywhere without using a car very easily, and I only have to wait 3 or 4 minutes for a tube or a bus. So that's fantastic. But my beef is that there seems to be an assumption that the only way to get high density is to go very tall, and that really isn't true. So like someone did a comparison of the density of Paris within the periphery compared to Beijing, and Beijing is very tall buildings, and they have equal density. And the trouble is that once you go taller than about 20 to 25 stories, then you need to have put in a lot more energy per usable square metre of floor to build that building, to resist the wind loads. You need to hand over a larger proportion of the floor area for your elevators. You need to put in energy to run those elevators, and you need to put in energy to lift services like water and the people all the time. So I think we have to be very careful. And the other thing that happens, of course, with tall buildings in a lot of cities around the world is that they're not really increasing density. those apartments, this is particularly in residential high-rise buildings, are being used as investment vehicles. They are just, as Peter Rees said, cash boxes in the sky. So they may not increase density at all. So I absolutely agree that we want density, but we have to be very thoughtful about how we provide it.
Anyone want to jump in before we...
Well, Paris is not the same density as Beijing. Beijing is 250 people per hectare, Paris is 60. And we do that density very, very carefully. And there's a lot of people don't, because they just take the area of a city within the municipal boundary of responsibility, not where the actual city stops.
Yeah, I was talking within the periphery.
Yeah, and that's not a reasonable comparison. The reality is that if you you have to do those numbers very carefully. But if you want to put to actually increase density in an area, it's very hard not to go up because the space to do a Paris or a Barcelona where you only have 5 stories or 8 stories is just not there. We've filled it with low density housing. So you've just got to have little spots where you can do density higher. And that's why cities are doing it. And that's the demand. The demand is there. But you have to do it better than the English public housing did. We've got this terrible legacy from the English who hate high density because they did such appalling stuff with the old public housing. And we copied you. And everybody in Australia hates high density because of it. So there is a need to do density well.
A lot of the tower blocks in the UK, which people didn't like living in, was because it was poor people living there and they couldn't afford to pay for a concierge and have good, the building well looked after. Some of those buildings are now private and people have been enjoying living in them. But we have to provide housing for people of all wealth levels. And the problem is that we're now in London building a lot of buildings around Battersea Power Station. They're not exceeding my limit, they're 17 stories high, but there's only 8 metres between them at street level. So that ground there is never going to see light of day. So there's no point just providing a lot of accommodation if people are going to be terribly unhappy when they're there. And it's not just in the UK. In Vancouver, they've been dealing with it quite well because they've been building a kind of podium level up to 3-4 stories, and then a few tall buildings in between. They're making sure they're keeping their views of the mountains, and so they're concentrating on what is going to make the environment pleasant, and I think that's really important.
Geoffrey, you want to jump in, and then Lena? Yeah.
This is not my expertise, neither high-rises nor really questions of details of density, but I was going to bring up this question of the English flats and the high-rises by English standards, because I had the great pleasure early in the week to be the host of the Housing Development Board, HDB, right? I got it right? Of Singapore, which has created all this public housing. 80% of Singapore is public housing, and it's all these big high-rises, exactly what Peter was talking about, the high density, and it's very, there's tremendous pressures here for that. But I was immediately thinking of the council flats in London, which I'm very familiar with, and the disasters, the post-war disasters in terms of community and sense of being and so forth. And that was in such marked contrast to at least what I saw and the image I was given of what has happened here. And it was very apparent why, very quickly, because it was clear that when Singapore did it, it's the only place I know, they were conscious of the idea of community and of space and separating those buildings and creating also, in terms of community, there would be shops and even a sense of a town centre within this. Whereas in Britain, there was this just building these damn things for people to live in, much as what's happening in China and has happened in other parts of the world. So that's a great success story, and I think relatively unique what I know, that Singapore, another one of those great attributes of Singapore, in contrast to, if you walk out of this room and you look across the bay and you see all those beautiful high-rises, all those marvelous buildings there, and it's beautiful at night. And of course, that's exactly what you don't want, because they're all hotels or offices, and no one lives there. And anyone that spent any time in Singapore knows that if you go walk through there at 8 o'clock or 9 o'clock at night, or on Saturday and Sunday, which is what I'm going to do, it's a ghost town. So the center is dead. So I think it's a no-brainer what Peter is saying about density, but it has to be done in a way that produces community and also enhances the soul of the city.
And let's bring it to Lena for that, because I was going to ask you that in any case, and if you could bring nature into this discussion as well.
Yes, exactly. I was going to say that, yes, there's density, but if you go back to first principle, the designing a healthy, productive city, and if we work on the principle that biodiversity is important for health, a productive city, because if you're healthy, then you would be productive. And therefore, it is so important to introduce biodiversity into not just the surroundings, which we try to do, but also at all different levels of the building. And which is why, because birds, butterflies, all occupy different altitudes. And if you provide that kind of environment at different levels, you would have the pleasure and the experience of actually experiencing it. So back to this, so based on this, that biodiversity is important for health, and therefore the National Parks Board have come up with a Nature Conservation Master Plan. Very simply, we do a few things. One, you conserve the biodiversity because you need that gene pool.
Right.
The second thing is, can I carry on?
Yeah, sure.
The second thing is...
Carry on.
Carry on. So, second thing is to connect, because cities fragment natural areas. So we connect it, and we do it using science. So using satellite images, using drones, how do we actually best connect? So ecological connection, very important. And third, most cities have degraded their natural ecosystems. So we therefore must rehabilitate, restore, enrich all those places that we have degraded, destroyed. Even recreate ecosystems. Look out for what are the ecosystems that we're lacking. In Singapore, all our streams have become drains. So let's revert them back. And that is why do visit Bishan Ang Mo Kio Park. It's a wonderful example. Go to Singapore Botanic Gardens. There's a wetlands there, right 10 minutes away from Orchard Road. So you rehabilitate, and the next thing is we need science. We cannot emphasize the importance of science, and therefore we need to collect information, data, scientific data. And the more challenging one is we used to just collect what species we have, but the ecological interactions between species, the challenging one, and that's one, because you don't know, you might lose a pollinator and then you have the tipping point. So those are the kind of things we're looking at now, ecological connections, and very important too, we need to actually engage everybody. That's where citizens come in, scientists, the government, plus very important businesses, 10 cents around, businesses, very important. And the last pitch, and that is we need to monitor what we have, and which is why we've come up with the Singapore Index on Cities Biodiversity that actually measures the biodiversity in cities. And it is done over, a period of time so that we know how well we are doing after 3 years, 4 years, whatever. And that, by just collecting information for that index, you actually galvanize the government, the scientists, the people, the NGOs. So that's the way of bonding. So that is why we think that in order to develop a healthy, productive city, make biodiversity conservation a core, and a core, a goal to meet.
Great, thank you, Lena. Quickly, Peter, yes.
Just quickly, I have to get a plug in for Nature Springer new journal.
Okay, we have more time for that.
The new journal, which I'm the editor-in-chief of, is called Sustainable Earth. And we have a special themed edition on biophilic cities and the science of them. The science, the policy aspects, and the community understandings of it. Because the science is actually pretty well known now. Biophilia was defined by E.O. Wilson, who is the Nobel Prize-winning scientist, as being something we need in our daily lives because we co-evolve with nature. So in our cities, we need to be near nature on a daily basis, not just go on a weekend or something. So this is how you build it into the city, and this is what Singapore is doing so well. But the science of that is that you can build hospitals with biophilia built into it, as they've done at KTP and others, all on our film, by the way. It shows that pulse rates diminish, that the blood pressure goes down, that healing rates increase if you are close to nature and can see it. That's all you need. There's something very quieting, and it helps us relax, and the right hormones and so on are released. So all of that science is understood, and we've written about it in various places, and we're collecting some of those articles for this special edition.
Great. Yanhua, so density, last question on density. How does it affect how city planners design energy and transportation systems? It's a big question, but I want to give you the opportunity.
I think it's not just one or two things that we have to look at. In a city, there will be complex interactions of all kinds of things, from biodiversity to happiness to health. But there are also other things like waste management, contamination, pollution, and also energy. So when you talk about this in a sustainable city, we have to look at the complex interactions between all of this. That also links in transportation. Because if you have different densities of cities, and the examples that Peter gave just now, all the way from LA to Beijing to Paris, you see these different densities, actually different designs of the cities, and you have to try to use science. I think science is a way to go about it. Gather the data, information about all that is going on in all the different areas that we want to improve. How do we save more energy? How do we reduce the waste that we dispose of? How do we make people happier? How do we get to have more nature in the city itself? Gather all the data with the technologies that are available already. I think we can come up with solutions that can be used for the city that we have. Singapore is a good example of what Jeff said. Singapore can do it for the townships that we have. So actually, it's almost like the spoke and hub model that Peter mentioned. You have the spokes of the different townships, but unfortunately, the hub in the downtown core becomes emptier during the weekends. But it's a solution. So is that solution the optimal solution for all cities around the world? It might not be. So we have to use a smart way, maybe a systems approach to decide what is the best way for the city. So we are looking into that, coming up with a model that can be used maybe globally.
Right. We've been talking about density, infrastructure, that sort of thing. I'd like to switch a little bit to the people in the city. And Jane, so I want to start with you. You mentioned earlier really briefly about depression of inhabitants in high-rise buildings. What about the psychological effects of cities on people in terms of healthy, well-being, productivity, high-rises and other situations, and how do you counteract that?
I totally agree with what's been said about seeing greenery in nature. But also, if you don't have to get into the bubble of your car, if you can use public transport, I think that again, provides chances for you to interact with other human beings. When you're actually designing buildings, it's definitely been shown in student accommodation that if you open your door onto a very long corridor and you don't know who's going to be walking past you, your level of stress rises and actually stays with you all day. Whereas if you break that corridor into smaller parts, maybe clustered around a kitchen, and so you'll only maybe see 10 people that you'll know, then you're going to be happier. Also, if you look at plans of buildings, I've been on quite a lot of design review panels in the UK. If apartment blocks are designed so that there's long corridors with no window at the end, so it's all enclosed, then you're going to be less happy. So again, it comes back to what I'm always saying, which is put yourself as a human being in the plans of what you're designing and imagine what it's going to be like. I mean, we can be happy in many, many different kinds of places. You know, you can be in these tiny chalets in Venice, only a metre wide, or you can be in a very wide boulevard, and you can be happy in both of those situations. But it's a question of how they're organised and how you're likely to bump into people.
Lena, can you add to this, because everyone today has been pointing to Singapore about, you know, from the airport on, you see hedgerows all the way to the city. And you mentioned a number of bird species. How much nature can you really have in a city before it kind of gets in the way?
Yes, that's a challenging question that we're facing now. Like, for example, at one time we didn't have hornbills in Singapore, or at least there weren't hornbills nesting in Singapore. And then they came back one fine day, and then we started putting nest boxes, but now the numbers have gone from a pair to like over 50. So now that is why monitoring is important, and find out, oh, maybe if there are too many and they're eating little, you know, lizards and all that, we should actually stop putting nest boxes. So monitoring is extremely important, and get that feel about what actually is the carrying capacity of each of the species. But back to this, I think it is so important for us, and we totally understand that it's not just greenery around us, which is why Singapore is a city in a garden, which means that it's not just a conglomeration of gardens, but the minute you open the door, you actually are inside a huge garden. So that is what we are aiming for, which is why even the roads form a very important part of that greenery. And it used to be much more structured and more manicured, but now we've adopted a much more naturalistic approach, which is why the roads are planted such that you have nice big trees, but in between there are lots of native biodiversity as well as shrubs, so they accommodate, you know, biodiversity as well as human beings. That we are hoping that it will come to a natural kind of a balance in that sense, and it also helps us to adapt, mitigate, and build resilience against climate change, using biodiversity.
Yeah, Jane.
I'd like to ask you a question. So, obviously here you have a climate where you have flowers all year round, and everything it's very easy for it to be green all year round. I spent a week once in Sweden, and it happened to be in April, and there wasn't a blade of grass, there was no green whatsoever. And I sometimes wonder, what can you do for people in those cold climates?
Well, we've actually had the challenge too, because desert cities were asking us about that too. But you'll have to find other ways. You've got to find adaptation. I can't give you the answer because I live in the tropics. So we've got to see what are the other plants. Could you then have cacti?
Maybe we have to integrate winter gardens more into those city designs.
Yes,
but I think we have to think about that as well.
Right.
But I think it's not just flowers, but just the presence of, you know, trees, and trees are beautiful without any leaves on it. Yeah.
Yeah, I think we need to be inclusive in our biodiversity and not just think of it as being the only native species are allowed. We have this debate in Australia all the time, but cities are very different habitats to what was there before. So you have the opportunity of altering the niches, the habitats, in terms of height, in terms of light, in terms of temperatures, in terms of how much water they need. And all of these things can be adapted. But it's a science. It's a new science to how to put them on buildings, attaching them, doing them inside. I mean, wouldn't this be such a better space if we had greenery on racks and on all around here? You know, I mean, the reality is we don't think about it to do it in places like this, but we think about it in our own homes. We're starting to do it in offices a lot more. But we do need nature all the time around us. And the science of doing that has got to go beyond landscape architecture, which is always just between buildings, to being inside, on and around, and our cities are then filled with nature.
That's it. We didn't rehearse this, but another nice segue to Geoffrey. And a few more minutes and we're going to start questions, so I hope you're still taking notes. Geoffrey, so obviously there's a lot that comes into play when designing cities to promote good health and productivity. Is there a way to pull all this together? Can we develop some big picture qualitative understanding of how cities should work?
Well, I'm not sure what you're looking for in that question.
An answer.
Yeah, that's what I was afraid of. So, you know, this, what I described earlier, this incipient science of cities, in quotes, that it's been dubbed, is an integrated view, and it takes seriously the idea that a city is a complex adaptive system. It's continually evolving and changing. It's made of many different components. And one of the very nice surprises that makes a science of cities possible was what I mentioned earlier, that almost all the metrics that you can measure about cities all have the same kind of scaling behavior and indicating that there is an underlying origin to all these and that there are fundamental principles. So, you know, how far you can take that is not clear, but clearly at a coarse-grained level. So, for example, you know, one of the things that comes out of this, both in terms of the data and the theoretical derivations, is that you know, every time you double the size of a city within an urban system, you get 15% savings on all infrastructure. So in that sense, you know, bigger is better. There's an extraordinary economy of scale. You need less roads, you need less gas stations, et cetera, what I referred to earlier. But at the same time, all socioeconomic activity increases by 15%. So on the one hand, you get the saving per capita for the infrastructure, and you get this extraordinary gain per capita of about 15% on the average of socioeconomic activity, whether it's you know, the good stuff, wages and patent production, but also the bad stuff, disease and so forth. So you know, so you can get a big picture view of how a city functions, a kind of idealized view of how it functions, and I would say halfway answering your question, maybe not even halfway, but, is that when thinking about cities, when even some of the questions that have been discussed already, but thinking about developing a city, mitigating problems in a city, or building new cities, which is of course a major challenge these days with the continuing exponential growth of the population. One should be aware of these. One should know that there are these constraints that are operable, that at the 80–90% level there is a dynamic that is hidden from us, so to speak, that is independent of all the urban planners and the urban geographers and the urban economists and the politicians, that there's this dynamic going on that is quite organic in terms of the way the city develops and grows in this sort of coarse-grained, low-resolution sense. and one should work with it, and that's the basic point in this. One should work with that, and not just rules of thumb or intuition or what architects think buildings should be or this development should be, but recognize that it has to be congruent with these kind of, I'll use the word, natural laws. In that sense, I think we can start to address some of the bigger questions, and perhaps the most important one, and that is not just the sustainability of individual cities, but the sustainability of the entire socioeconomic urban system. And we could talk about that further.
Actually, I'd like you to talk about that for 1 minute, and then we'll go to questions. So if you go to the deputy mayor, who keeps being brought up today, or the mayor, or city planners, or the councilman, or whoever it is, and you tell them that cities should be conceived of as an evolving, complex, adaptive system, how do you get them to at least take a longer-term perspective?
Well, yes, I mean, you have to, and I do talk to quite a lot of cities and such people. Is first of all to try to understand what is happening to a city within its own context. So one of the first obvious things is we have these extraordinary scaling laws. So what does that mean? That means that you tell me the size of the city, I can tell you within the sort of 10 to 20% range how many police it should have, how many AIDS cases there should be, how long the road should be, what the average wage should be, for a given city. So you can then look at your city and ask, am I over or underperforming? And why is that? Why is it that we have, instead of 297 police, we have 345? Is that reasonable or not? Are we outliers? And is there good reason for that? Or is it just because of some weird political decision that was made? So it's that kind of context that one has to introduce these ideas and integrate the science, so to speak, with the urban planning and the political decisions that necessarily have to be made. So, I would say that that should be extended and is being extended way beyond just an individual city, but of course to entire urban systems. And ultimately, as I said a moment ago, to understanding why it is that we're facing the sustainability questions that we face. And just let me finish with one thing. In biology is completely dominated by economies of scale. The bigger you are, the less you need per cell. Across all of biology, entirely in a systematic, predictable way. And it is that which ultimately leads to something extraordinary about biology, and that is that we continue to eat and metabolize, but we stop growing. And stopping growing is intimately related to the fact that life has been around for 2 to 3 billion years. We invented extraordinarily this amazing collective behavior, this amazing engine to do things that we're doing now, to talk and interact, create ideas and wealth. And that has led to this superlinear behavior. The bigger you are, the more you have per capita, which leads to open-ended growth. And it in fact leads to faster than exponential growth, which is what's been happening. And so to understand that in the context, in the bigger picture, I think is crucial, because that inevitably leads to collapse, not just of an individual city, but indeed of the entire system. So understanding what that dynamic is, where it's coming from, what is the mechanisms that's leading to it, I think is ultimately crucial for having a conceptual framework for understanding long-term strategies, including global sustainability.
Great. Peter wanted to jump in, but I also want to start the questions. Do we need one of the mics for questions?
It'll just be very quick.
Great. So while you're getting queued up here, Peter.
if you want to get long-term perspectives, you don't go top-down, you go bottom-up. The community understand long-term values and visions. They're the ones who look after that legacy. It's their grandchildren they're worried about. If you have top-down solutions, and I regard smart cities as a top-down solution, it's an idea that somehow or other, if you get that technology in place, everything else will trickle down and get solved. It's nonsense. You have to get to know what is your outcome you are looking, and that's got to come from the bottom up. And those processes, when you tap them, are amazingly powerful. A very quick example, in my own city in Perth, we're not branded as a smart city, but we are now, the biggest power station in Western Australia is rooftop solar, put on by every normal householder just trying to look after the long-term future. And so now we're getting together, and the utilities are having to work around creating citizen utilities, local blockchain, shared systems. All of the new technology is now being used, but it's being driven by the community demanding this, not by having some smart city dream that says we're going to get to be zero carbon. If you don't touch the people, you won't get the long-term outcome.
But totally out
we have
of
a question
order.
here.
Wasn't that driven by tax incentives, or is that completely in the Perth? So my parents live in Sydney, and they put lots of solar cells on their roof. But that was largely tax
solar
incentives.
has a very small federal government incentive to it, but almost nothing.
Okay.
The price of solar in Perth is half the price of American PVs.
All right.
Because I want to strongly endorse what Peter said.
Yeah, okay, go ahead.
No, in terms of the two points, the top-down versus bottom-up, I think is absolutely crucial. You can elaborate on that. But also, this bandwagon of smart for everything, not just smart cities, as a panacea for solving all of our problems, and from a physicist viewpoint, the idea that you can have just big data, machine learning, artificial intelligence, mix it all up, and out pops the solution to everything, is extraordinarily dangerous because it has built into it facile behavior without understanding. And I have, and this may be a faith statement, without understanding, without deep understanding and serious science, which that is not, in my opinion, I think it's delusional and dangerous.
On that note,
It's very important that we do these things. I don't want to decline
Yeah.
to do all those things, but we need to put it in this context and balance it.
Ed's going to take your microphone. Lena, we'll get to you too.
Okay, I've been identified a lot today, so I should remark. And I think Peter's sort of he's doing the good thing that a panellist should, and he's firing people up, which I like. But just a couple of things, and I guess it's a question for everyone, is understanding the truth out there in cities. I think sometimes gets clouded by other levels of government, so whether that's state or nations. And I couldn't agree more that a lot of nations and indeed a lot of states seem to be very focused on election time cycles. But when you look at a lot of the cities, particularly in networks like C40, they are developing plans for 10, 20 years, 30 years, 40 years. And then the other part of that too is that they're putting out projects. So, for example, the Melbourne Renewable Energy Project, which the City of Melbourne drove, is a 10-year power purchasing agreement. So I think, the question is, how many conversations are you having with cities and truly understanding what they desire? And then just on the rooftop solar, when it first came out, the rebate was nearly half the cost of a rooftop solar system. It dropped to about a third, and it's coming down all the time. But I think, what are the examples that you've seen where good government regulation combined with bottom up? Because I think if we get into this, well, it's either got to be bottom up or it's, top down's bad. It's a bit of a dangerous way to look at things, because I think where I see great outcomes is where you get astute policymakers that understand that good policy actually drives innovation. And then that's supported by a really good community engagement process, which is often bottom up. So I think where the two meet is probably a really good place to be. So I'd be interested whether you've seen any good examples of that.
Anybody want to jump in?
Yes.
Yes, meaning?
Yeah, top down and bottom up have to meet. But it's a question, I mean, you're in a top down position and you mentioned community engagement after you got your plan ready. I'd just be a little bit more humble about that process. That's how you said it.
We'll have to pass the mic around here. Lena wanted to jump in too, though.
Sorry.
I've lost it. It's actually related to bottom up, and I think what we need to do is increasingly globally and in Singapore too, we need to ask the youth, because they are the future generations and they have quite different ideas from what we have. And the reason is, if you start planning every bit of use of land and not take into consideration their wishes, their aspirations, then we're actually eating onto their inheritance. I think it's not just bottom up, but actually the people who actually count, who's going to live the future, need to be incorporated into the decision-making process.
So, in this bottom-up, top-down context, so in addition to studying organisms and cities, I study companies. Is there a science of companies? And I got into this because one of the things that I found most intriguing that's related to this is, why is it that all companies eventually disappear? All of them. So, you know, Google and Microsoft and the rest are going to go. The average lifespan of a publicly traded company in the United States that's already publicly traded is about 10 years. It's unusual. It's a true outlier that's 100 years. You start to ponder why. Why is this? And it's related to this very question of top-down and bottom-up, because companies, by and large, are top-down. In a certain sense, they have to be, but some companies have tried not to be. But they're top-down, and without going into any details, top-down leads to mortality, I'm afraid. Whereas cities are not, by their very nature, top-down. They can't be top-down entirely, and a great city and great leadership of a city has maybe an intuitive sense of how much needs to be run like a company and how much needs to be run as a community, and real sensing of where the city is going in terms of people and the sensitivity to social interaction, social network, culture, and all the other things that go along with it. So it's a very interesting example, because they're both, cities and companies are both organizations of human beings. And they're both social organizations, and they have completely different life histories. And by the way in which they scale is completely different. Related to these, very much related to these questions.
Let Yenhua have a word, and then, are there other questions out there? Yes? Okay, good. Well, I want to get more questions in, so quick, go ahead, Yenhua.
I just want to throw in this thought. The top-down versus bottom-up approach might depend on the society that you're in. So in the Asian society, a lot of the people, the public, they generally look for a top-down approach. I say this just using one example. Say how you throw away your waste. In Singapore, if you don't have a top-down approach, a lot of people would not bother recycling. They would not throw their waste into a proper container. You will not see Singapore so clean in a sense, because for some reason, if you don't educate them, that's another point I want to make. For some reason, the behavior is to just naturally go down to the lowest common denominator. And it might happen in the Western society also, but in different societies, there's different approaches or public behavior. So the second point is, as scientists, we need to educate the public on whether it is better to have a top-down or bottom-up approach, but what is the outcome that we want the public to aspire to. So even in the Western civilization, for example, you have people who are conservatives like those who support Donald Trump, and they don't believe in climate change. But if you don't have the scientists educating them properly about the effects of climate change, and just tell them that climate change will increase the temperature by 2 degrees, but what will happen, as we were talking about it last night, then they won't have an incentive to go a bottom-up approach. They won't go into solar energy or wind energy or whatever. They oppose it fervently. So we need to look at the society that we're in, and as importantly as scientists, we need to educate the general public about this so that we can do more of these bottom-up approach.
Great. Another question.
Hello, I want to, actually it's one of my suggestions. I think in such of skills of the summit or any conference, we really ignore the one group of the persons. They are actually as the stakeholders of the key stakeholders when we're talking about the sustainability, it's about the children. Because when we're talking about sustainability, actually we are thinking about the generations after generations. However, I think in the panelists or the politicians' view, we didn't talk about too much, or we didn't take too much children's view or their opinions when we discuss about this kind of the topics. So my suggestions is later on when we have such skills of summit or anything, why we not invite a group of the children or teenagers to get their point of views, how they want our city or our country to be like, how can become a healthy and smarter and productive cities in the future from their point of view.
Great, thank you. Anybody have a quick comment? We have about 5 minutes, by the way, so if you do have a question, put your hand up and Ed can get you the microphone.
Hi, thank you. So I have a question for Mr. Peter Neumann. And,
sure.
So I think we're hearing a lot about the conversation between the top-down or bottom-up approach in designing cities, and I can't help but ask if there is a certain level of idealism here that we have to address up front. Let me explain what I mean by the idealism. See, a community in an ideal case is able to decide its long-term direction if there is a consensus. Now we know that consensus is not something that's easily achieved. I use America as a clear example. We have a carbon divide between the rural states and the more progressive states in America today. And that has resulted in rippling political implications all the way to the federal government itself. So when we say that there is, a bottom-up approach is great, is it an ends-all, means-all sort of thing? If you don't have consensus, and if each community within a country, within a body, within an organization has their own selfish desires, how do you address that?
So, anyone, how do we walk that line between consensus, because consensus can be difficult to bring together?
Yeah, look, consensus, you have to develop consensus at some point, otherwise you can't move anywhere. And stuck societies, I can think of one large one at the moment, where they just can't seem to get consensus, apart from in the cities, but you have to get it. So, and there are approaches to it. They're called deliberative democracy approaches, and these are happening even in places like China, where you actually involve not just the people who are stakeholders, as in, they've got a beef about something, they really want this to change, not just them, but you involve the experts, which we've done before, but the third factor that they do is bring in citizens for the day, people who don't have a point of view, but are keen to be involved in a discussion. And they always sway the consensus-making process because they form the glue that links the opposing forces. that deliberative democracy process is being used around the world now in many different societies, and I would recommend that you look at that if you're keen to find out how you get consensus. Bottom-up processes are a science as well. They really are, and there are real experts around now on how to do that.
Yeah, I'm gonna have to stop. We're gonna have to stop there. So I'd like to ask each of our panelists 30 seconds, one takeaway, that's it. Lena.
I think I mentioned that takeaway already, but I'll
We can repeat
reiterate it again.
Repeating is good.
Yeah. So there are the 5 C's. So first, conserve biodiversity. Second, connect them. Third, create, enhance, restore natural ecosystems, basically. And then you've got to collect data, which is the science bit. And finally, collaborate, coordinate, cooperate. So basically, comprehensive involvement of all sectors. Everybody needs to get involved. So the 5 C's, yeah. Thank you.
I think there are 8 altogether. Peter, go ahead. 30 seconds, one takeaway.
Yeah, this new journal that I'm editing, Sustainable Earth, has 3 subtitles.
Three subtitles,
just so
yeah.
you don't forget. The subtitles are science, community, and policy. And the 3 need to be joined if you're going to get any solutions. I think Scientific American actually does this, so we're sort of copying.
Okay.
But you get the science right. It's not enough. You have to relate it to policy and change, but you also need the community to understand it and help drive it. So you've got to get the values of it right. You've got to shape it. That's where the bottom-up part comes. And those 3 things fit together.
Great. Yinhua.
My one takeaway would be that we need more understanding and more data for the city. At the moment, we are just scratching the surface of being a sustainable and healthy city. So we need to collect a lot more data and a lot more understanding before we can figure out what to do.
Thanks. Jane?
There's a developer called Bioregional Quintain, and at the beginning of every large development project, they would get together everyone involved in the project, including the stakeholders, anyone who would be affected by it, the people who are going to be working on the design, who are going to build it, and collectively they had to write a happiness plan. And I think that this is a good way to start any large project or big master plan development.
Yeah. Geoffrey, 30 seconds.
At the risk of repeating myself, no, I feel very strongly that we need to develop a scientific framework based on and try to understand the underlying principles by which cities, urbanization, and its relationship to sustainability actually function mechanistically in a kind of quantitative, predictive fashion, which brings in some of the things that were said. We certainly need more data, but frankly, we need more ideas. We need much more ideas, and we need to, and that's why I was so passionate about the smart stuff, that I think it's moved away from ideas. And so I really feel that if we're going to save ourselves, we need to think much more deeply about this. And it's particularly important because time is accelerating. Things get faster and faster. And I'm going to do one thing that I never do, but I'm going to do it. I'm going to shamelessly, since you promoted your journal, I'm going to go much further. I'm going to promote my book.
I've got a copy, it's good.
Yeah, it's good. Yeah,
It's good.
So read my book because I try to say some of this. Thank you.
Thank you. Thank you all. I appreciate your time. Thank you all. I appreciate your time.